Good afternoon on today's Angry Bulletin. 3.8 days to Mars, 10.8 days to Jupiter, 1.65 years to the nearest star? This is beginning to sound a bit impossible, but it's the kind of propulsion we would expect to see from extraterrestrial civilizations who regularly visit our planet. But is such a propulsion system actually possible with technology that we can even imagine? And if so, have we seen any evidence of this kind of propulsion already having been used right in our neighborhood? All of this and more coming at you on the Angry Astronaut right now. Good afternoon, and once again, welcome to the Angry Astronaut. Not calling this one an Angry Alien Bulletin per se, even though there is a connection to a UFO sighting with this particular type of propulsion, but the majority of the video is about the technology itself and not about the incident. However, if you'd like to learn more about the incident associated with photon rockets or photon starships, well, there's definitely a video for you linked at the end of this one. But to quickly summarize, in 1952, the Mount Palomar Observatory spotted three bright objects where they shouldn't have been. Three bright objects that appeared there for a brief period of time, then vanished, never to be seen again. Now, these objects could not have been any sort of natural phenomenon. If we're talking about supernova, flaring stars, or asteroids, anything along those lines. For one thing, very rare to see three of these objects clustered together, but also these sorts of natural phenomenon occur over the period of days, not hours. In other words, if you had spotted three brightly flaring objects, they should have stayed put for more than just a brief period of time, which they did not. And if they were asteroids zipping past our planet, well, they would have left a streak on the time exposure photograph, which they didn't. Instead, they were objects that were either in geosynchronous orbit or heading directly at our planet, or something that was so far back in the stellar background that they were essentially part of all the other stellar formations, all of the other astronomical objects that the Mount Palomar Observatory was seeing that night. And as I said before, these objects could not have been anything natural. And neither could they have been anything man-made, because in 1952, we had nothing in orbit at the time. It would be several more years before the Soviet Union would launch Sputnik into orbit. However, in terms of theorizing what these objects might have been, by the way, nobody had any idea that they were even there until a team of astronomers found them on a collection of digitized photographic plates taken from the Mount Palomar Observatory as part of a general study of their observations back in the 1950s when we didn't have satellites cluttering these photographs up. Well, after this discovery was made, one particular reporter, journalist, or whatever you'd like to call him, YouTuber, and his name is John Michael Gaudier, and I find it to be a very reliable source of information. He's very conservative about what he reports on and doesn't make these kinds of statements lightly. He suggested the possibility that these could be photon rockets, photon starships on approach to our planet. And why did he come to these kinds of conclusions? Well, the night after these objects appeared in the skies above Mount Palomar, one of the most dramatic UFO incidents in the history of this planet in Washington, D.C., a mass sighting of UFOs confirmed by several different radar arrays transpired. So we're talking one of the biggest mass sightings of UFOs taking place the day after these objects appeared in the night sky. Very interesting coincidence indeed, and perhaps one of the only examples of a direct connection between extraterrestrial objects and famous UFO sightings. But once again, this video isn't really about that. Instead, after he suggested the possibility that these might be photon rockets, I became interested in the technology because I had never really reported on that. Yeah, I had reported on photon propulsion, that is to say, lasers pushing light sails between stars, or powerful radio waves, a variety of different methods used to provide propulsion to a starship without having any fuel on the ship itself. One of the few ways that you might be able to realistically approach maybe 50, 60% of the speed of light, something that would give us realistic interstellar capability. But the photon rocket is something entirely different. Something that doesn't require the sun, something that doesn't require lasers on a faraway planet, but instead is entirely self-contained, and yet could still achieve speeds of up to 98% of the speed of light. And at 98% of the speed of light, it brings many, many star systems in our region within our grasp. Within a realistic time frame, a ship could reach a wide variety of destinations within 50 light years or perhaps even further in a realistic time frame. And if we can imagine a technology that could do this, might somebody else have already done it? And might they have visited us in 1952? On the night of July 19th, 1952, three optically bright 15th magnitude point sources within 10 arcseconds of each other appeared in the night sky above Palomar Observatory and then vanished within 1 hour. The 3 point sources have continued to be absent in telescope exposures during 71 years, with detection thresholds of down to the 21st magnitude, meaning that whatever these things were, they have definitely vanished since then. They obtained 2 deep exposures with the 10.4 meter Gran Telescopio Canarius on the 25th and 27th of April of 2023, reaching all the way down to magnitude 25.5, and the 3 point sources were still absent, implying that they have dimmed by more than 10 magnitudes within an hour back in 1952. This is impossible, at least for a natural object. Any sort of supernova, flaring star, or anything like that would have been still there after several hours, definitely could not have vanished that quickly, and a passing asteroid or meteor would have left a streak on the time exposure photograph. But what it does resemble is a rocket of some kind, or 3 rockets applying thrust either to accelerate away from our planet or decelerating. Now, these could almost certainly not be chemical rockets being incapable of traversing the distance between stars, at least not in realistic time frames. Just to give you an idea of how inefficient chemical rockets are compared to other power sources, let's go ahead and do some comparisons with energy yields. A kilogram of liquid oxygen / liquid hydrogen combination yields 1.35 times 10 to the 7th power joules. A kilogram of uranium-235 subjected to nuclear fission produces 8.2 times 10 to the 13th power joules. That's 6 million times as much power per kilogram. And it gets even more powerful if we're talking about nuclear fusion. A kilogram of deuterium and helium-3 subjected to nuclear fusion will produce 3.52 times 10 to the 14th power joules, approximately 4 times as much energy as a nuclear fission reaction and 32 million times as much energy as a chemical reaction. Once you start talking about that type of energy, then you can start realistically talking about interstellar travel. Although not really. at least not in a realistic time frame. Even utilizing the vast power of nuclear fusion, the fastest you can realistically get is about between 3 to 8% of the speed of light. And the reason for that is the vast majority of the fuel that you're converting into energy is wasted. That is to say, in a fusion reaction, only a tiny percentage of the matter is actually converted into energy, and the rest is waste matter that you have to eject from the spaceship. Yes, it's a much more efficient conversion of matter into energy than chemical or even nuclear fission, but still not good enough to get anywhere near the speed of light. Now, a possible way around this is the plasma created by a fusion reaction is ionized, and if you direct it out the nozzle with a magnetic field, well, that plasma is going to be traveling a substantial percentage of the speed of light, and you will get a much more efficient use of your fuel. Might be able to achieve 20% of the speed of light with that kind of propulsion system. Some argue that you could get even faster, but nowhere near 50% of the speed of light, 98% of the speed of light. That's still well outside of our reach, even with fusion power. So what's next? Well, antimatter, obviously. Now, before you start scoffing, antimatter exists in our natural universe. It actually exists in Earth orbit, and that may come as a surprise to some of you. In 2009, the Fermi Space Telescope, which was designed to detect gamma-ray emissions from distant points in the universe, suddenly started picking up bursts of gamma-ray radiation coming from thunderstorms on our own planet. The first time this happened with Fermi was purely by mistake. Fermi was supposed to be detecting gamma-ray bursts from very distant sources in the universe, sometimes millions of light years away, and that's what they thought Fermi had picked up, NASA that is, in 2009, but instead, what had happened is a burst of gamma-ray radiation had been created by a thunderstorm, and further, another burst of gamma-ray radiation suddenly impacted the satellite's solar panels more than once. So how did this happen? Well, thunderstorms generate high-energy electrons which collide with atoms. This in turn creates a burst of gamma-ray radiation. What happens, unexpectedly, is on a rare occasion, when these gamma rays impact another atom, this creates an electron and sometimes a positron. A positron being a particle of antimatter. These positrons are ionized by their very nature and in turn picked up by the Earth's electromagnetic field. The electromagnetic field then carried those antimatter particles into direct collision with the Fermi satellite, and they hit the solar panels, creating this burst of gamma-ray radiation when the antimatter annihilated the matter that was inside the solar panels. Now, granted, only a single particle was annihilated by the impact, so it didn't really affect or damage the satellite, but it did definitely trigger its gamma-ray detectors. And what appeared to be a gamma-ray burst from the distant universe was actually a gamma-ray burst being created by antimatter in our own magnetic field. Antimatter that was isolated and protected by the matter around it by the magnetic field itself, and the only reason that it was destroyed is because that magnetic field came into contact with the Fermi satellite. What this means is there's a lot of antimatter trapped in our planet's magnetic field. Now, by a lot, we're talking maybe a couple of kilograms or something like that, but still a considerable amount. And if you're talking about a planet that has a much more powerful magnetic field, such as Jupiter, well, you might have a lot more antimatter, perhaps tons instead of kilograms. And then the magnetic field of the sun, well, that's even more. So if you could harvest that antimatter in a magnetic field the same way that the magnetic field of our planet protects the antimatter that exists in orbit around the Earth, well, you could use that antimatter as the ultimate rocket fuel. Rocket fuel that is converted 100% into energy with almost no waste mass whatsoever. So pure energy conversion, which produces a hell of a lot more energy overall for your rocket and brings interstellar travel very much into the realm of possibility. With matter-antimatter annihilation, you get 9 times 10 to the 16th power joules. That's 200 times the power generated by a deuterium helium-3 fusion reaction. And just to put things into perspective, 6 billion times as powerful as a chemical rocket. So how does this work anyway? Well, the best way to harness a matter-antimatter reaction, at least according to some scientists, is a photonic rocket, an antimatter photon drive. Well, how does that work? Well, the principle is to direct the positron and electron beams of this engine towards a collision point at the focus of a parabolic dish placed at the extreme end of the spacecraft. Each annihilation will release 2 gamma-ray photons back to back, where one or both photons will impact the parabolic dish depending on how big and extensive the dish is. When these impacts take place, there will be reflected, assuming that you make a dish that's reflective enough, and that provides your thrust. So instead of having a dish that you reflect normal photons off of, like a laser sail or a light sail, instead it's reflecting the gamma rays being produced by the matter-antimatter reaction. And these gamma rays contain almost all the energy produced by that reaction. You're losing almost no energy whatsoever with this type of engine. Now, this is definitely beyond our current technology. We have no way to 100% reflect gamma rays with our current technology, although there are some theoretical methods that might allow us to do it in the future, and also this type of engine would generate some truly lethal exhaust. The gamma rays being directed behind the spacecraft would be sufficient to kill just about anything behind it, including targets on a planet. As a matter of fact, it's possible that the gamma ray bursts that we pick up from time to time, that we sometimes associate with black hole formation or the collision of neutron stars, that sort of thing, could also theoretically be coming from an engine just like this. I'm not saying the gamma ray bursts are definitely coming from alien super engines, but then again, if they did have that kind of technology, we would expect to detect these kinds of gamma ray bursts from time to time, actually with a fair amount of frequency. And so what kind of performance do you get out of an engine like this? Well, it's truly unbelievable if you compare it to the types of rockets we use today. For a 400 metric ton rocket to get to Mars, first of all, you would only need 1.3 metric tons of those 400 tons to be propellant. The rest could be the rocket itself, and it would only take 3.84 days to get to Mars, assuming 1g acceleration all the way. If you're talking about Jupiter, 3.765 metric tons of propellant for a 400-ton rocket, and the travel time is only 10.8 days. And then if we're talking about Alpha Centauri, well, at 10% of the speed of light for a 400 metric ton rocket, only 53.9 metric tons of that mass needs to be propellant. The rest of it is the rocket itself. This sort of ratio is unheard of with most rocket equations. And then if we're talking about 50% of the speed of light, still only 170 metric tons of the ship needs to be propellant. Less than half is propellant, the rest is made up of life support, cargo, whatever. And the time to get to Alpha Centauri would be 9.59 years, or 8.41 years as experienced by the crew. As I've said a number of times, funny things start to happen when you travel close to the speed of light. Time passes more slowly the closer you get to the speed of light, and at 98% of the speed of light, the difference is very striking. 5.12 years is the actual time to reach Alpha Centauri at this speed, but the crew would only experience 1.65 years having passed, which puts many, many different stars within a realistic striking distance of Earth. There are actually 1,300 solar systems within 50 light years of our planet, or roughly 12 years worth of travel time for a vehicle traveling about 98% of the speed of light, with a total of 1,800 stars in these 1,300 solar systems, with who knows how many planets, certainly at least 10,000 or so. With 10,000 planets, 10,000 shots at possible intelligent civilizations springing up, and it's not beyond the realm of possibilities that one of these civilizations sent out some explorers headed our way in 1952, and we picked up the glow of their photon rockets decelerating as they entered our solar system to pay us a very exciting and very public visit in July of that year, over 70 years ago. I have a very exciting announcement for all of my Patreon supporters. We have a members-only live stream for alien Q&A, UFO topics only, tomorrow. I hope you guys can attend. We will be announcing the time of that live stream very soon, and if we can get 4,000 likes on this video, 4,000 likes, then I will have a live stream again oriented towards a UFO UAP Q&A for everybody, not just for Patreon supporters, and I will open that up the moment we get to those 4,000 likes. So please like, please subscribe. Also, please consider supporting this channel on Patreon, and as always, stay angry about space.